Hey everybody! Before I teach you anything today, I'm going to have you make a little prediction. We're going to be talking today about what if an exponent is negative or zero. So take a guess. Why don't you? Make a prediction here. What do you think 3 to the negative fourth power equals? What do you think 3 to the 0th, if that's even a word, power equals? Take a stab, make a prediction, and pause and then unpause when you are ready to go. That was all right. As I already previewed it rather than predicted, today I want to talk about how to evaluate an exponent that is less than 1. Make this the title on the next 3 pages of your math notebook. Once you have done that, mark that page, close it up, clear your space of any distractions, give me maximum brain power for a couple minutes, and I'll tell you when it's time to write. Some words. You saw this word in the title, evaluate versus simplify. Just as an idea, we've talked about things like, say, this expression here, 2 to the second, 2 to the third. Simplifying that would be saying 2 to the fifth. Just simplifying it into easier expression. Evaluating it would be figuring out what this actually equals. Like second power is 4, then 8, 16, like 32. So evaluating this is like figuring out what number it's equal to. Simplifying it is just simplifying the exponents. We're going to be doing this today, but we don't always. And then another thing, you saw this word in your title. When we look at this is the base, and this is the exponent. Exponent you probably knew, just this word we tend to forget. This is called a base. And we have dealt already, let me go back before we go, with what happens if the base is negative. Something like this, that means negative 2 times negative 2 times negative 2 times negative 2 times negative 2. We figured this out last time. Sometimes this is positive, sometimes this is negative when the base is negative. In this case, negative, it would be negative 32. We haven't dealt with what if the exponent is negative or even 0, less than 1. And that's what we're doing today. So here we go. So these are the ones I asked you about in the preview. What do you think is 3 to the power of 0 or 3 to the power of negative 4? I bet I can read your mind. Hang on. I'm going to do it. Let's see if I can read your mind. Get a calculator here real quick. Makes 3 to the 4th power if it was positive. 3 is 81. I bet you said this was 0 and this was negative 81. That's my prediction, is that was your prediction. And they're not. What a 0 or negative exponent is surprising, though it isn't hard necessarily. Here's how I want to show you how to figure it out. You're going to notice a pattern real quick. I want to work back. What if I start at 3 to the 4th power? Then work back to 3 to the 2nd power, then 3 to the 2nd power, then 3 to the 1st power. We know all those, right? 3 to the 4th power is 81. 3 times 3 times 3 times 3. 3 to the 81. 3 to the 3rd power is 27. 3 times 3 is 9 times 3 is 27. 3 to the 2nd power is 9. 3 times 3. And 3 to the 1st power is 3. So if I look at those, there's an obvious pattern here, right? If I go up, I'm always multiplying by 3. That's what I'm doing. 1 more 3, 1 more 3 than the last one. And if I go down the list rather than up the list, the opposite's true. To go from here to here, you would divide by 3. You're multiplying by 3 one less time. Here you would divide by 3, multiplying by 3 one less time. Here you would divide by 3, multiplying by 3 one less time. So if you think about that pattern, when you work down this list of exponents, you're always dividing by 3. What if I went 1 more down the list? 3 to the power of 0. Well, it's actually not 0. You keep on. You're dividing by 3 one less time, or multiplying by 3 rather one less time. So you keep dividing by 3 when you work down this list. And it turns out 3 to the power of 0, 3 divided by 3 is 1. It is not 0. It is 1. Like I said, that's surprising, though it's not hard necessarily. Actually, anything to the power of 0 is going to be 1. You can do this for any base, working your way down the list, and no matter what you do, anything to the power of 0, as we're going to see further in here, is 1. What about 3 to the power of -1? Well, keep working down that list. And 1 divided by 3 is 1/3. It is not a negative number even, if you'll notice. It is positive 1/3. You keep dividing by 3. 3 to the power of -2. Well, that is 1/3 divided by 3. Remember how we divide fractions? We do 1/3 times the reciprocal of the second fraction. So that turns out to be 1/3 times 1/3, which is 1/9. Positive 1/9. And now you're going to start to notice some stuff as I keep on this list. Notice 3 to the -1 versus 3 to the +1. Then notice 3 to the -2 versus 3 to the +2. Right? You're going to notice that pattern, and that continues. 3 to the power of -3, 3 to the power of +3 is 27, 3 to the power of -3 is 1/27. And that pattern continues as well. 3 to the power of -4, 3 to the power of +4 is 81, 3 to the power of -4 is 1/81. And you never have to memorize this. All you have to do is keep dividing by 3. As long as you can divide by 3, or divide by whatever the space is, you're good to go. So that's how 0 and negative exponents works. Anything to the power of 0 is 1, and then negative exponents are the same as the positive exponent, except in the denominator rather than the numerator. 1/9, 9, 1/27, 27. So that lets you do things pretty fast. This is still I do. So like, without having to do that calculation every time, though we're still going to write a few notes, 5 to the power of -2, the way you can kind of figure that out is 5 to the power of +2 is 25. So 5 to the power of -2 is 1/25. Super quick, right? -6 to the power of -3. Well, if I did -6 to the power of +3, I'd get -6 times -6 is 36. Times -6 again, I think that's -216 if my memory serves me right. So if 6 to the power of +3 is -216, then -6 to the power of -3 is 1/216, or -1/216, right? 3 to the power of -10, now we start to get where like, I don't want to figure out what 3 to the +10 is. It's going to be a gigantic number. But what I can say is whatever that is, that's the same as 1/, whatever 3 to the power of +10 is. So I can just simplify it sometimes like that. You could figure out what 3 to the 10th power is. That's just going to be a real big number, and I don't feel like doing it. So sometimes when you see a negative exponent, instead of evaluating it like that, you can just write 1/, the positive exponent. Whatever 5 to the second power is, it'll be in the denominator. Whatever -6 to the positive third power is, it'll be in the denominator. That's okay too. And -7 to the power of 0, super fast. Anything to the power of 0 is always going to be 1. We'll do another example in the we do, and you'll see it always comes out at 1 when the exponent is 0. All right, let's start here. So in your notes, let's do, oh, never mind, one more I do. What if you see -3 in the denominator? So we notice like 7 to the -3rd power is the same as 1/7 to the +3rd power, whatever that is. Same thing can happen. You notice we kind of move the exponent from the numerator to the denominator and just make it positive. You can do the same thing when it's in the denominator. If you see a negative numerator in the denominator, you can also just move it up to the numerator. It's the same as that, right? 7 to the 3rd power and 1/7 to the -3rd power are okay. So you can always just kind of bump the exponent up or down in the fraction and make it positive or negative. That's one last thing to know. All right. Let's do these in your notes today. All right, so this is going to be the same thing I did before. I'm going to write the chain just so you get used to where this comes from. I hate you to just memorize stuff and not know why. So I'm going to start all the way up at like 2 to the 4th power, 2 to the 3rd power, 2 to the 2nd power. This is so if you ever forget how to do this, you have a way to do it. You never have to memorize what these negative exponents are. You can figure it out. So 2 to the 4th power, let's go up. 2 to the 4th, first power is 2. 2 to the 2nd power is 4. 2 to the 3rd power is 8. 2 to the 4th power is 16. And so we're always like multiplying by one more 2, right? But today, it's more interesting to move down that list and divide by 2 because we want to go farther down than 1. So here I'm dividing by 2, dividing by 2, dividing by 2. And the next thing down that list would be 2 to the power of 0, new one. So if I divide by 2 again, surprisingly, 2 to the power of 0 is 2 divided by 2 is 1. Yeah. And then 2 to the power of -1 seems like it should be -2, but it's not. Because we keep moving down that list. Divide by 2 again. 1 divided by 2 is 1/2. Go down that list again. Divide by 2 again. Seems like it should be -4. It is not. Because 1/2 divided by 2, half of a half, is 1/4. And notice it's not -1/4 even. It's +1/4. And then 2 to the power of -3, divide by 2 again, is 1/8. And you'll start to see these comparison ones, right? Like 2 to the -1st and 2 to the +1st closely related. 2 to the -2nd and 2 to the +2nd closely related. So that's where it comes from. That's how I want you to know where all this stuff comes from. And you can know these. You can end up doing stuff pretty fast if you know that. So whenever you see a negative exponent, if you want to pause and write these, please go ahead. Whenever you see a negative exponent, it's the same thing as putting a positive version of that exponent in the denominator. So it's going to be the same as whatever that is. -2 to the 3rd power happens to be -8, so we can know that this is like -1/8. But that's your step. It's like negative when it's in the numerator, you just make it positive in the denominator. It's going to be the same thing as that. 4 to the power of -5 is the same as whatever 1 over 4 to the power of +5 is. That one I don't know. It's going to be pretty big. Pull my calculator in here. 4, 2, 3, 4, 5. 1 over 1,024. Notice this is simplified. This is evaluated. We use those words early. Doesn't matter which sometimes. You'll usually be asked one or the other. This is 1 over whatever -6 to the power of +7 is. I'm not going to evaluate that. And 13 to the power of 0, well, that is just 1. Every time. Exponent of 0 evaluates to 1. And one last thing, what if you see, the negative exponent in the denominator? Well, that's the same thing as kind of like moving it up to the numerator and making it positive. So 1 over 4 to the -7 is the same as 4 to the +7. So that works too. So just like we would be able to say 4 to the -7 is the same as 1 over 4 to the +7, we can do the same this way and say, 1 over 4 to the -7, you can also bump it up to the numerator and make it positive. So you can always bump exponents up or down and just change the sign without having to do all that work ahead of it. All right, y'all. That, my friends, is how negative exponents and zero exponents work. It's kind of a big new thing, especially these two slides really focus on understanding. I think this one tends to make a lot of sense. But if you got kind of stuck as I worked on these expressions where I moved stuff around and changed the exponent sign, please give this a go again if that was confusing. Thanks for your attention, and I'll see you tomorrow.